Hello, hello. Do you like jazz? Because I do. Where is it? Here I am. What's up, guys? What's up? How are you guys all doing? I hope you're doing well after that freaking hard tournament or contest. Here we go. So let's start with the easy questions so we can pretend like we're smart. Okay, so you did your first problem at 1 hour 10 minutes, like the easy one. I'm gonna stalk you if you don't mind. Okay, you came in late. Yeah, okay. So beer bottles. You are given an integer n representing n full beer bottles. Given that you can exchange 3 empty beer bottles for 1 full beer bottle, return the number of beer bottles you can drink. So basically this problem is about division, but you need to keep track also of the remainder. So you have to add an extra variable here, empty, and like n here keeps track of the number of full bottles. So when you drink them, you can add it to the answer, and every bottle you drank becomes empty, and then you check the current number of empty bottles divided by 3 becomes full bottles. But you also need to keep track of the remainder modulo 3. So we can use div mod, and the second parameter returned here is the result modulo 3. So that's the only issue I could see with this problem that I saw a lot of people submit and get wrong answers with. So that was pretty much the only edge case, I guess. Any questions on that question? I don't think there's much to discuss here. If n is smaller than 3, return n. You did a recursive. Yeah, seems a bit overkill, but whatever works, man. Okay. So actually, about this question, I did something really bad, guys. I have a confession to make. So I took this and did this, and I found a lot of things that are really interesting. Like I spent I spent a lot of time trying to figure it out by myself, but people already did it for me, so what the hell, we're in the contest setting. I'm not gonna waste any time trying to understand it. And like, it's really tricky, I think. Yeah, I found this this LeetCode link, and apparently there's like this exact same question on. It's not even a question, it's just a discussion, it seems like. So like, here he asks the same question. Given 2 strings with the same length, can like split and do the combination of both strings. So what I did is like, I copied this and put it here, and then added some extra edge case testing where like A or B is already a palindrome. So we can try to understand this. I don't know if it explains it. Okay, let's look at this. get via 2 pointers the longest A1, B2, where A1 and B2 have the same size. What is he talking about? Okay, let's look at the code. So it's a 2 pointers, you start at both edges. I have no idea what this variable means. So at the start it's false. So at first it checks the string A and string B, and if they're not equal anymore, it tries to track the string A. I'm just gonna try to draw it out to see if I can make sense of it. So let's say we take the example given here. Cat and B equals pack. So at first I is here and J is here. If they're equal, it's fine, he just increments the I and J. So it goes that way and that way. And since I and J meet, it means like there's a cut in the middle that brings them together. So that example is not really representative. We could try this one, for example. Yeah, sure, I can link it. But I don't know if it's an actual question. Yeah, okay, it's just a random post on the forums. So if you find anything that explains the procedure more in detail, let me know and we can look at it. But I only see code snippets. So yeah, sometimes it's good to try to find something online, even though it's not super legit, man. You gotta do what you gotta do to win. But yeah, now we should try to actually understand it. Okay, so this here. Okay. So we start here. Our little I, well, we can draw an arrow to represent I, okay? So let's say at first there's an arrow here, and we have an arrow here. Okay. So I'm gonna draw it like this. Okay, so we're here and here. Okay, so now I is smaller than J, A switch is false, so we reach this point. AI is not equal to BG, so it like switch J to like here. So it's like trying to form a palindrome with the rest of the string that wasn't matched. Fi return false. Like if I remove this, I think it's gonna fail in that case. Yeah, exactly. Okay. It's like not dealing with the case that strings are complete palindromes. There has to be at least one cut. Okay, I kind of get it. So basically what it's trying to do is like match the palindromes from the edges of the string, and when it's not matching anymore. Like here it's not matching. So one constraint of a palindrome is that like the two edges are equal and the center is a palindrome as well. So if we look at a race car, like the R at both edges are equal, and then you can check if the center is equal. So now it's doing the same thing, but when there's not a match between A and B, it's like doing a fallback on A, and now we're like trying to match the center that it's only considering one string. I think we can modify this to like look at it from a B's perspective as well, and it should work. Yeah, okay. So it's trying to greedily match as much as of B as possible, and when the match is not possible anymore, you try to do a palindrome from only A. So like, you know, both sides of the center are palindromes. So if A at the center is a palindrome as well, then you're okay. And for some reason that works in O of N. You don't have to look at offsets, because I think they're just a sub-problem of the original problem. Yeah. So you can greedily just start from the edges, and when it doesn't match anymore, then you try to greedily find a palindrome from the center, and if you reach the intersection between I and J, like here, then you know it's a palindrome. So that's one problem with greedy algorithm, is that it's super hard in some cases to prove that it's always correct. And like intuitively, I kind of get it, because they're all checking the same sub-problems at the same offset. Like if you decide to start from here and here, actually you have to use all of the string in your cut, so you're forced to start from the edges. So in that case, you're forced to start from here. Yeah, okay. Does it make sense for everyone? Like, it kind of makes sense for me. Kind of. I can try to re-explain it. Like, if it doesn't match B, you can fall back on A. But even if A switch is the moment you try to... Okay, so let's take like a regular palindrome like race car. If you match the edges, you can like work on the sub-problem in the middle. So you know, if the middle is a palindrome and the edges are like the reverse of each other, you're fine. So basically what this is doing, it's like taking the left edge of A as this part. This is the right of B. And the switch basically means you're not equal to B anymore. So you try to take as much as possible from A in order to like match this center. So this is like the switch. So when you know you can't make a palindrome out of the like right part of B, your last hope is basically that the rest of A is a palindrome at the center. And the reason like I do both sides here is like to try to find a palindrome inside B as well. Yeah, it's kind of not obvious, but I think the logic makes sense. It's like take as much as B as possible, and when they don't match anymore, you try to match the rest of A that wasn't matched as a palindrome, like if it was the center. And then you try the same procedure with B as a reference. You try to match as much as B as possible, and when they don't match, try to take the center and check if it's palindrome. Yeah. Any more questions? You have 5 seconds to answer. 1, 2, 3, 4, 5. Okay, we can come back if anyone wants me to come back after. Okay, this one. So this one I spent a lot of time trying to do it as dynamic programming. And it was kind of working, but I always ran into time limit exceeded. So like I tried like spending some time optimizing it, turning it into like a bottom-up DP, but then I have so many problems trying to keep track which numbers were picked and which weren't. Because usually like in dynamic programming, you only care about like the answer, like the length of the longest subsequence or whatever. But now you want the actual numbers, so you need to keep track like which numbers you picked in your optimal solution. So yeah, that was kind of annoying, but I realized by doing my DP that like you always try to minimize like the first number, like the front, and then you have like a sub problem to the right of the smallest number in the next range after it. I'm gonna draw this one out and it's gonna make a lot of more sense. But yeah, the actual solution is greedy and I'm gonna show why. And I think I kind of can prove this one, that it always works. At least by intuition, but not by formal proofs. I have no idea how to do that. So let's take our example here. Okay, so there we are. Okay, so we want a subsequence of length 3, and we want it to be as lexicographically small as possible, which means you want the first number to be the smaller of the first possible numbers, basically like a string. Like when you compare the first number, it has to be smaller or equal than all the other possibilities for the first number, and then for the second number, all those constraints as well, the other numbers as well. So you want your first number to be as small as possible. That's the point I'm trying to make. But you want to be able to make a subsequence of length at least 3 in this case. So one thing you can do is leave enough numbers to the right to make a subsequence of length 3. So here 2. And in those numbers, you want to pick the smallest number possible. So in this case, it would be 0. So by picking a number in this range, you know you can pick any number after it and you're at least gonna have enough numbers to make your subsequence of length k, and that you're gonna have the minimum possible number for that position in your subsequence. Because let's say you included this number and like this number was the smallest, then if you want to pick any number to the right, well, you're not gonna have enough numbers to make a subsequence of length k. So you look into this range, and this range is bounded by the length of nums minus k. So you know you have enough numbers for the rest of the subsequence. So you find the minimum in that range. So here it's gonna be 0. So let's say you have like your answer at the end here. So now you add 0. So now you kind of have a sub-problem. So maybe you can express it. You could say it's dynamic programming because there's sub-problems involved. I don't know if it's not really overlapping, so maybe not. But you find this, and then you have like the same procedure repeated. But now instead of, I can like draw the same array again. Instead of searching in this range, you're gonna search in the range like after the last number you picked and length minus k, but now the k is gonna be reduced. So let's say we have our same thing here. But now here k equals 2. So you're gonna search in the interval after the last number you picked, and k, the length of nums minus k, well, it should end up here. So you have, once again, enough numbers to make a subsequence of like at least 2. So if you pick the rightmost element, you can still pick this one and you're gonna have 2. So here we have 9 and 2, so we pick the smallest one. It's gonna be 2 here. So 2. And now the same thing for k equals 1. You're just gonna have a 3 here. So you pick the last number that's remaining. I can draw it again for clarity. So 1, 2, 0, 9, 3. This. And now you search in this interval, the minimum value, and you pick it. And now since k is equal to 0, you're done and you have your answer. How did you think of this during the contest? Well, I did not think of this at the start. I just tried like so many things. I think it took me like 1 hour to figure this out. But like I felt like this was dynamic programming, because I kind of saw the structure that you want to pick like the minimum value for the first, and then you had like a subproblem with like k minus 1 with the index after. But I just like had a flash that you could just do it greedily. Like there's no process to it. It's like, I don't know, it just came to me. Seeing that like the subproblems could like be picked greedily. You did not need to know like the result of the other subproblems to know like that the first value, if it's smaller than any of the other values that you pick for the first number, you do not need to explore the subnodes of the other numbers. Like here, if I choose 0, you know it's gonna be better than all the numbers here, all the subsequents that start with 2, 1, or 9. So there's no reason to explore them. So we can look at the code. So here I have my answers array that is this blue thing I drawed out. Left is the left bound for our blue interval here, so this here. This is our left. And this is gonna be our right bound for our interval. So yeah, length num minus k. So while there's numbers left to be picked, we keep track of the index of the smallest number and the... Hi Sasha. And we keep track of the value of the smallest number. Then we iterate over every number in the interval inclusive of the right. And we check if the current number is smaller than the minimum, then we add the index. Then we add the minimum in that interval, we reduce k, and then we update our interval to be to the right of the last number we picked, and then making sure that there is enough values to complete our subsequence. And if we submit, we pray, and it should work. Okay, it works. The speed is kind of shit. I'm curious about what the others have written. Yeah, with a stack. Interesting. Can iterate. Put each number in a stack. If they are bigger, it's still possible to fill the stack with at least k numbers. Okay, it's kind of the same logic. Okay, yeah, it looks like a min queue, because here I'm gonna iterate over some... Yeah, I'm gonna have some overlap when I iterate. Like, let's say if the 1 was the smallest value, then like I would need to iterate over all those values here a second time, so there would be some loss here. So I think in the worst case it could be like n squared. So maybe that my solution will be eliminated when they add more test cases. So it's definitely worth looking at this, like using a min-q should be prioritized. But it's the same idea, just optimizing the operation of finding the minimal value. N times n minus k. Maybe. I don't know. Minus k, let's say like k is... Yeah, it makes sense what you say. Yeah, the size of this interval is always length minus nums minus k. It's really close to n squared. That's what matters. Okay. So are there more questions about that question? I think once you get like the intuition, it's clearer, right? Let's do fourth. Let's go. You have a lot of faith in me. Okay, so how do we do this using min-qs? So I think this one is what it's implementing. It's using min-q, kind of, or like using a stack. So it's not exactly min-q. So let's think about it. We would iterate in this range and like add all the elements in the min-q. Then once we're done iterating over that range, we know that the smallest value will be at the left of our min-q, and everything to its right is gonna be larger. So it means in our min-q there's gonna be nothing left of the things to its left, because this number is the smallest. So when you have the smallest value, everything to the left is eliminated. So I think if you just pop the left element of your min-q, you should already have like the numbers here. So you just need to add the values to the left here. So here you would just add the 2 to the min-q, and it should work. Does that make sense? Rami boy. So instead of like setting left here to index plus 1, you would set this to the max of index plus 1 and of right plus 1. So make sure you don't add the same numbers to the max q. Min q, I mean. I keep saying max q, right? So that should work fine. Do you want me to like actually try it? I really want to go ahead and like bust my head on the fourth problem, if you don't mind. I think we're gonna have a lot of fun with it. Maybe cry a little, but it's gonna be an enjoyable experience. Connect Forest. Let's go, guys. We can do this. So, you're given a two-dimensional list of integer graph representing an undirected graph by an adjacency list. The graph is a set of disjoint trees. You can add a certain amount of edges to the forest such that it becomes a tree. Return the minimum distance possible between the longest path between any two nodes. Okay, so I think for this problem we're like forced to like draw everything out and try to like gain an intuition on the problem. So let's draw some trees, shall we? Okay, I'm done. Okay, so now for the actual problem. So let's say you have like your forest here. I'm gonna draw some random trees, as random as I can. So this is a tree, now you have another random tree here. Like maybe something simple like this. Maybe like a tree with only one side. So what we want is the minimum distance possible of the longest path between any two nodes. So one thing I noticed is that we can start setting a lower bound for an answer. Because we know, like at this point we already have like, here we have a minimum longest path of 4, like without connecting anything. Here the longest path would be 3, and here it would be 3. So I think there's a medium problem on this platform that just given a regular tree, you find the longest path between two nodes. And I think you can do this in linear time by just doing it recursively. It would be like for each node, it's the longest path going through that node or the longest path to the left of it. Yeah, you check like the max between the path of the children or the path going to the current node, if that makes sense. So here we know that the answer is like at least 4, like without connecting anything. The only thing that can happen by connecting any nodes is that the answer gets larger than this. And let's look at like the worst thing we could do. The worst thing we could do is like connect a leaf to another tree. So connect a leaf to another leaf. Here the longest path would go like to the furthest leaf here, and like go like this. So I think for every tree we have in our graph, in our forest actually, we have to find the nodes with the smallest distance to any other node in the current tree. So like, let's say, what am I doing? Okay. So let's say for each node, we can compute the minimum length between that node and any other node in the current tree. So this one would be 2 because it's like 2 nodes away from this one. Same for this one because it's 2 away from this one. This one would be 1, 2, 3. Okay, yeah. 3 excluding, so maybe including the current node would be more accurate. So 3, 3, here it would be 4. So we find the maximum path for each node, starting at each node. And we know we don't want to connect trees starting from the nodes that have the longest path, because it's only gonna add the maximal answer for the longest path. So we probably want to find the nodes with the smallest paths, like this one, and connect it to the node with the smallest path from another tree to minimize our answer. But now there's like combinations to take into account. No, I think it would work, yeah. Like in all the trees, I think you want to find the node with the smallest path of all the trees. And then for every tree, you find the node with the smallest path in that tree and connect it to the node with the smallest global distance. Smallest, longest global distance. That makes sense, right? Okay, so let's continue here. So we can mark this in another color to make it pop. So this one, so maximum this in red will be red. I'm gonna make a little legend for you guys. So it's, how do we word it? It's the longest path. So we have 4, 3, 3, and 4. Here we have 3, 2, 3. And here it's the same layout as this one, so 3, 2, 3. Okay, so I think one interesting thing to note here is those nodes here that have 2 as a distance. What happens if we... Maybe I should do another layer here. Okay, so I'm gonna redraw those trees. So we had this and this here. So 3, and 3, 2, 3. So my intuition is that we want to connect those 2 trees like that. And this is still a tree, it's just super ugly. If we redraw it again, it's gonna look something like we have our... This is the first tree, but then we add the second tree. It's gonna look something like that. Like originally, the maximum path from those 2 nodes was 2 and 2. But if we recompute everything, now this one is gonna be 1, 2, 3. 1, 3 once again. But the edges are gonna be affected the worst. So 1, 2, 3. 1, okay, it's 4. Yeah, it's 4. So 4, 4, 4. So yeah, it's fine. So maybe this is not the best example, because since the trees are so simple, it just added 1 everywhere. Since from each root there was only 1 path anyways, it just added 1. Right? So we could try a more complex forest. We could maybe take the other example. This one. This has 2. Okay, let's do more drawing, guys. This is an art stream now. Okay. So let's make a longer one. Let's go crazy. So let's say this, this, and maybe like another node here. Okay, something like this, and then another, let's say a complete tree like this. I'm doing binary trees. I don't think it matters. Probably doesn't. It doesn't matter. Okay, looks good. So now if we label the nodes again by the maximum distance they can reach in the current tree, so this one's going to be the worst. So 1, 2, 3, 4, 5, 6. We have a winner. 1, 2, 3, 4, 5. This is going to be the same. This is going to be 6 as well. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5. 1, 2, 3, 4. And this is 1, 2, 3, 4. Okay. So now this one. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 4, 4. Okay, so if we connect the node with the smallest maximal distance to here, we have two possibilities. It shouldn't matter which one we pick. So now let's combine them. Okay, so we can redraw this one, I think. I'm gonna run out of space. Can I resize canvas? There we go. Isn't that much better? So once again we can redraw this tree. And now we want to connect it, so it's gonna connect here, so something like this. So this is this node here, so we want to put the left one right. Seems about right, right? Right? Okay, now let's label it. So the last time we connected, it added like 1 to everything, but now I think it's gonna change. So basically what we're trying to do is like derive a formula, and I think the greedy logic of like finding the nodes with the smallest maximum distance is alright. And I'm willing to like try it out to see if it actually works. Yeah, I don't see any other way that you could find an optimal answer. I mean, Bunny's probably here, he can tell us, right? Bunny, are you here? Crab Milk is here. Crab Milk knows. Okay, so let's relabel. So here it's 1, 2, 3, 4, 5, 6, 7. Yes. So once again we added 1. 1, 2, 3, 4, 5, 6. Okay, it's because we had like only one level offset, and I don't think it changed. Yeah, it's just one level here that was added. Okay. 1, 2, 3, 4, 5, 6. Like it almost feels like it's always the roots that you always pick, except for the one where like it's not obvious where the root is. Like in this one, the root can be this one. Like if you just redraw it, so this one's on top, this one can be the root, this one can be the root. Like any node in the tree can be the root if you want it to. So it has nothing to do with the root. It's just the smallest distance you want to pick. Okay. So I feel it's just for each node the distance to the smallest node. Okay, let's look at that. So when you have this node here, like currently the longest path is like this here, but when we connect the other tree, you either have the choice to like keep this path, or we have the distance to the node with the smallest distance plus 1. Now you reach the node of the other tree, and now you just add the maximum distance of this one, so you like reach here. So you take the max out of those two answers to find your new result. We have to do that in linear time. It's not super obvious how to code this. Like we want to like, how do you even compute the maximum length for every node in linear time? Like, it's not that obvious. Like, if you start at this node here, it's like the maximum path of this node plus 1 plus this node plus 1, this node plus 1. But now you can't go back. So if for this node the longest path was by here, you can't reach it. Maybe you can find longest path in 3 from every node. Okay. The diameter. You can find the longest path using 2BFS. So I think this runs in, they don't even give the complexity, but it's probably, since it's 2BFS, it's probably a linear time, V plus E. Does this give the distance for every node? If we start BFS from any node X and find a node with the longest distance from X, it must be an endpoint of the longest path. Okay, I get it. I get it. So you want, okay, you find the extremities of the tree. That's just gonna give us the longest distance, so it's not gonna give us the distance from every node, because let's say you start at any random node in a tree like this one here. You can do BFS and you're gonna reach like the extremities here. And like you tell, when there's no more neighbors that you haven't seen, then you reach an extremity and you can save it. So you can save the extremities from the tree like that with one BFS. So now you have those nodes. Okay, I get it. So find the max distance to any node. You start from the extremities like that. And each time you explore a new node, like like let's say this is one BFS iteration. Now you're here, here, and here. Now you check if it already has a distance set. If it already has a distance set, then you check if the current distance is larger, because there's gonna be some overlap, I think. Oh, it's not working quite. Because you want this node to explore this node here to tell it it has a distance of 5 here. Yeah, 5. 1, 2, 3, 4, 5. Or you can find the max distance. The distance from here is the distance from here plus 1. You can do it recursively like that. If you already explored the node, this one, I just don't know how it's going to interact when the two overlap. Okay. Do you guys have any ideas? Please help me. Please, I need your help. Longest path. I want to see if I find anything. Okay, so longest path. I want to find the maximum distance. Okay, this is what I want. This is exactly what I want. Think of the, okay, this is good. We're making progress. Think of the tree as unrooted, just a graph where each node has a bidirectional edge that form no cycle. Good. For a given node P with adjacent nodes, say AI, we will compute the height. HPAI, nice variable names, is the height of the subtree with root P. If you're interested in the longest path from each node to a leaf, I think this is accurate. Like, it's always the longest path will always reach an extremity of the tree, or else there's always like a longest path to explore. So that's about right. It's just max HPAI for all I. So like we find a temporary root. It's like the height of the current node plus the height of the extremity, if it's not a child. This is fucked. Let's keep looking. I don't care about going through P, I just want the max patent entry. We have the heights for each node. Okay, we can do this in constant space, finding the heights of every node in the tree. So we start from a random node in the tree, we consider the root, and then find the height for every node. So this is going to be like 1, 1, 2, 1, 2, 3. Now we can find all the heights. Okay, there's some code we can look at. I still don't see it. Each node is labeled with its own number, then a length, a longest path that contains it. Okay, let's hope the code will lead us to glory. So we have our undirected graph. It has a builder that fills the graph with random values. I want to unlock it, but I don't want to lose XP. Okay. So a node length. Okay, he even gives some weights to the edges. Is crazy, man. Okay. Does this matter? I want the function too. Okay, here's another solution. If you're the max of the height for all I. Does this make sense to anyone? Let's read this again. For a given, okay, think of a tree as unrooted, just a graph where each node has bidirectional edges that form no cycles. For a given node P with adjacent nodes, say AI, we will compute heights is the height of the subtree with root P. Obtained by considering nodes AI to be P's parent. If you're interested in the longest path from each node to a leaf, your question plus its title leaves doubt about what you're actually trying to compute. It's just a max. HPA is the height for all I. I is what? Is the height of the parents. How does this make sense? Like, this is all we need, but it doesn't make sense to me. Like, this is the height of this node. Like, if you tell me that the leaf we're trying to get to is not under the current node, I can just do the sum of this node and this node. And this is not even running in linear time, is it? Because you have to iterate over each leaves for every node. Oh, I think I maybe get it. So when we're considering the height of a node, it's not the height to the root, it's the height to a leaf, if I'm not mistaken. So this would be zeros here. Zeros, zeros, zeros. But we want to maximize that. No, I'm still at the same place I was earlier, trying to find the max path from a leaf. I'm not making any progress. I'm gonna try to ask some questions. Can anyone explain to me how to find max path? Hi Puggers. Hi Ruji. Oh, okay, yeah, this. So I'm gonna wait until someone helps me with this, because I feel once we find a way. So here's how I see this solution. You find the maximum path to any node from any tree. You can do that in linear time, according to the internet, even though they don't really explain it well. And then you want to find in all the trees, you want to find the node with the smallest maximum path. And then for every tree, you connect the smallest node, the node with the smallest path from every tree to the node with the smallest path globally. And then you find the relation to combine the lengths of the different trees. I think the solution is something like that, but I'm missing how to get the max path for a single tree. But it's doable in linear time. Then you have to deduce the math formula to combine two trees. And it seems to be the max path from in the tree plus no, it would be the max from the root plus 1 plus the max from the other root. Yeah, I think that makes sense. So we can draw it here. It would just update this case. It's the only one you need to look at. And this is the height of this node. This is the height of this node. And this is just a +1. So if you find the height of the smallest node, you can consider any root. And this one, then you can combine it with just the simple math relation of the sum plus 1. And you do that for every tree. And you should find the answer. So I'm just missing the maximum path for every node in a tree. Once I figure that out, I should be good, but I'm not sure if I can do that right now. How would DFS work? Like you start from any arbitrary, yeah, that's what I was thinking earlier. Like how would we do that with like either BFS or DFS? And like well, that's what they're saying in this, but I'm not sure how to derive the maximum path from the max depth. Like, you can find the extremities like this. Is it the max depth? Like in this Stack Overflow post, they call it the height. And the height is the height of the subtree with root p. But the thing is, there would be some overlap. Like, let's say this one is height 1, this one 2, 2, this one 3. Oh. Yeah, I want to look at them, but I have to lose XP. I don't want to lose the XP, man. Like it would ruin my perfect run. Like 12 problems away of completing everything. Can't help it right now. Yo, what's up, Bunny? I need your help. Please, man. So like I'm just struggling finding the maximum length of any path starting from every node in the tree. And I think I kind of can figure it out after that. Yep. Okay, let's look at that. Tree depth. It uses a heap as well. Oh, nice. So for any given node, thing that add. Okay. Okay. Heap q that e push dfs1 best single path. So basically you're starting from any arbitrary node in the tree, then you're finding like the maximum distance to any extremity like that. Yeah, I saw the diameter, but I'm not sure how it relates to finding. Faster than 6%, nice. But I'm not sure how you find the maximum path from every node using the diameter. Yeah, but don't you care about the longest path starting from every node? Like, my idea was like finding the maximum path from every node and finding the path with the smallest value and then using that node to connect to other trees. But you need to find the node with the smallest maximal path for that. So like here I would take the tree because it has the smallest maximal path. So when I connect it to the smallest maximal path, it will have the smallest combination of any combination for the trees. Okay, so does that actually work? Like, trying to find it. So here the diameter is 6. So 1, 2, 3, 4, 5, 6. Yeah, 6. But if you do 6 plus 1 divided by 2, it would give you 3. And here the min is 4. Is it like 6? And you like seal that? So now you have 4. Okay, I kind of see it. You don't really care about the nodes, you just care about the length. So for each tree you find its diameter and you find the middle of the diameter. So it's like the node farthest apart from the edges. And then using this value you can combine it to the other trees. Okay, if that makes sense. I don't see why you use the heap though. You only care about the min. Alright. And children. Try the 2 largest. Okay. So Python diameter. So I wonder, this is 1 squared. L R. Don't get why they're doing all this funky stuff. So the height of the current node is just the max of the children plus 1. So you return the height of the left and the right, and the max result going through that node. Makes sense. Let's try to do that. Now let's just set C. So there's a case going through the node. Node returns 0. Okay. So the height of the left node plus the height of the right node plus 1 current height is the max of the height of the left node, the height of the right node plus 1. So now we return the current height going through node. So I think we can find the diameter of a tree like this. See that add node like that. Continue. Diameters. So do I get all the diameters of the different trees if I do that? Int object is not subscriptable. Is it not? No. 0, 0 like that. Wait a second. This is an int. So our tree has many. Oh, wait a second. Okay, I see why you're using a heap now, since it's not a binary tree. Is that why? Has to be. So we want the two largest heights to consider the case where it's going through the node, and we want the max of the maxes. Yeah. So to track the two largest values, can max A, max B. Like using a heap is basically the same, right? Since it's just log n for each pop, and you're already constrained by the iteration Okay, I see, it makes sense. I just want to print this. So if there's less than 2 children, we can't check the case we're going through node. So going through node equals 0. If length 8 is larger than 1, then we can do this. This should maybe work. Maybe not. Segfault. Interesting. So where are we getting? Oh, right. Right. Had an infinite loop because we were re-exploring the parents. Okay, not enough values to unpack. That means we're not returning anything. Expected 2 got 0. If we don't have any children, what happens here? If we don't have any children, we just return 1, 1, right? Heap argument must be a list. Is it? It isn't. What is it then? Oh, it's a zip object, right? It's a tuple. Okay. Zero, 0, 2, 1. So it's saying we have, that doesn't make any sense, but we have 4 trees in this example, 2 of which have a diameter of 0. Zero, 1, 2, 3, 4, 5. Let's draw this tree out to see what we're dealing with. So we have 0 that's pointing to 1, 2. So this is 0. This is 1, 2. Okay, 1 is pointing 0, 2 is pointing 0, and 3. Like this. 0, 1, 2, 3 is pointing to 2, 4 is pointing to 5, and 5 is pointing to 4. So we have another tree here that's independent. Independently, financially, independently. Like that. So that's what we have. 1, 2, 3, 4, 1, 2. Something's not right. It's like those two nodes should be in this tree, but they're not considered. If not, this is bad. Can we just do that? For 1. There we go. Okay, we have our... Do we? This is 1. 1, 2, 3, 4. Heights going through the node. I think if we do that, it should work. Exactly. Okay, we have our diameters. So here we have a diameter of 4, like this, like this, like this, 4, and this is 1 and 2, so 2. So we have that step covered. So we know the upper bound for our answer is 4, lower bound. So lower bound is the max of the diameters. Now we just have to test all the connections. One, two, three. Smallest diameters. So now we should have the nodes. Oh, nice man, Parvish. 3 and 2. That's correct. Okay. It's modest. So if I equals ref continue, so like if we connect this to this, we'll have 1, 2, 3, 4. So it'd be 1, 2, 3, 4, 5. It's the longest. One, two, three, 4. I'm cutting the nodes right now, not the edges. So maybe I have to do okay. So I think we do this -1, and this we just do deep over 2. And return answer. What's this? Minimum distance between the longest path. One, two, three. 1, 2, 3, 4. Okay, this is the example I was thinking. So now we have this. I mean, I agree that it should return 2. So why am I returning 1? Let's print the diameters. All the diameters should be 1, right? Yeah, 1, 1, 1, 1. Zero plus. Oh. Oh fuck, that's nasty. Okay. Because like, kind of have to update the answer. Let's say we have like our empty trees like this. And like right now, the diameter of every tree is a 0. But we have to make 1 tree. So what I'm doing here is just like connecting it like this. But now there's like a new path created. So the diameter has changed.
So I think this +1 needs to be persisted.
The diameter, the smallest changes. The smallest ref. Come on, please work, please work. Ah, this is hell. Let's draw it again. So 0, 1, 2. So 0, 0, 0, 1. 2, 3. 0, 1, 2, 3, 4. So we have this. So I find the tree with the smallest diameter, this one, and I connect everything to it. Now this tree has a diameter of 1. And I'm overshooting the... So how is it supposed to do 2? Just care about the 2 largest diameters, right? One, two, three. How do they get? Huh. So we want the max diameter? Seems like. So I think the case where no node is connected should break here. Index out of range. So if length graph equals to 1, we return 0. So we have more than two trees. I think we need to set that as an upper bound. Index out of range, line 26 here. Now what? Hmm. 240, nothing 1. Yeah, this is hell for edge cases. Okay, so 0 is connected to 2. 0, 1, 2 is connected to 0. Okay, 1 is connected to 4. At least it's not like super huge test cases that you can't debug anything. For this I am glad. So, 0, 1, 2, 1, 2, 3, 4, okay, 4 and 1, and there's like 3 here all along. So I think you connect like everything like this. My answer is 2. 1, 2, 3 is the answer. How do we deal with that edge? It's like 1, 2, yeah. I think if we do +1, +1, and like exclude the extra 1 and add here, maybe it will work. Maybe not.
And here we are again. Let's break everything. I don't know, something like that. Maybe. Wait. Length diameters. So we have more than one tree here. Is this tree again? Yeah. Zero, 1, 2, 3. Maybe this 2 divided by this must be wrong on this one. And that only my guess because it should be working. 1, 1, 0. 1, 1 plus 1. Yes. So it should. Oh, it's a min heap. It's a min heap. Of course, it's. Man. Of course. Here we go. Let's try it out again and again and again. Zero. Zero, 0, 1, 5. Wait a sec. 0, 1, 2, 3.
4. 1 and 5. 0 and 4. 0, 1, 2, 3, 4. 5. Okay, it's like this, it's 1. So 1, 2, 3, 4. It's correct. What do my diameters look like? One, two, three. Wait, 1, 2, 3, 4. Not even close. Give me 1 second. So now I have to do like this. Fuck. One, 5, 0, 1, 1. 0 is missing. Is it? Two, 3, 5. Oh, okay. Oh my god, I didn't realize that. I wrote 5 twice. So it's like 5, 4, 1, like that.
Oh, I use the heap here as well. So of course I'm gonna... If only there was a max heap input. Stop printing right. Wrong answer. Ah, fuck, what did I do? Did I remove that? Where did it go? I just made it disappear. Please give me a time limit exceeded so I can remove the print and it works. Wrong answer. Ah, it hurts. All right. Okay, now we have to draw this again. Hello there. Hello. Hello, hello. Do you like trees? Cause I draw trees. That's what I do best. 0. Now 1 is connected to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is connected to 1. Okay. 2 and 8. And 8 is connected to 3 and 4. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a bunch of empty ones. Starts at 4, 5, 6, 7. Yeah, 5, 6, 7, 8, 9, 10, 11, 12. 10, 11. And yeah, getting messy. It's getting messy. One, two, three. So that's my answer, right? But the expected output is 4. Because when we combine this, there's a new path here. Oh no, you had to add 1 each time you connect. Some ends. I think you have to set the length of unique trees -1. So if I do this, I think I will overshoot the answer. But if I do -1, I will be fine, right? 4 expected 2. Did I cover this already? Yeah, I covered this 11 times. So -1. But I will still overshoot it because I will have this, this. And I will do this, do this, do this, and it's going to be 1, 2. So it's not exactly true. 1, 2, 1, 2, 1, 2. So why is this true? I feel like I have to iterate at this point. So fuck that. Smallest. Ah, if I sort, it's gonna time out, right? I don't have time to sort. Do I have time to sort? Oh, I'm sorting the number of unique trees, I think. Let's try it. So screw this, screw this. So when you connect this to this, 1, 1 creates 1, 2, 3, right? Can I have to maximize this, I think. Will this work? Convinced. I'm really not. Even this is not defined. Of course. So I think it's happening here. 1, 2, 3. So they're all
diameter 1.
actually 0, right? Yeah, okay. I'm adding 1 each time. So what happens here? Let's say I have like infinite. Empty trees. Like this. I can combine 2, combine 2, combine 2. That's, I have 2, still have 2, I still have 2, and I still have 2. What's happening when I combine 2? Do I have to minimize this? Doesn't make sense. I have to update it somehow. So ends equals max of ends and min dist plus smallest ref plus 1. How to update this? Does this work? Can remove this. Let's pray and get it wrong. Sure. Let's try it again. So 0, 1, 2. Three. Okay, that's the example, I think. 0, 1, 2, 4, 5. Like this. Now we connect the min of this one like this. So 1, 2, 3, 4. Yeah, okay, I agree. Let's check our state is correct for everything. 2, 1. So 1, 2, I agree, and 1, I agree as well. So 1, 2, 3, 4. I forgot something, I feel like. Did I? No, I didn't. The 2 plus 1 plus... That should work. And this plus smallest ref plus 1, okay. 3 isn't this. I mean, this smallest ref should be 2, 1. Yes? I'm not printing it. I think I have to remove this. Okay. Please, 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 please. Okay, nothing, nothing, 2, 3, nothing. Let's try it again. I feel like I draw the same problem all over again, like so many times. So we have this, right? So we can draw it like this. Just want to look at the side effects. 2010. I think it's correct. So what I'm doing actually right now is this 1, 2, 3, which is incorrect. I think I have to connect with the max then. Let's try this. Please work. Please work. Please work. Please. I'm so tired. Fuck yeah. It was about time. Well, we made it, boys. It took 2 hours, but we did this question, and it was glorious. Yeah, I'm done. Do you mind if I get some food first? Because I'm kind of hungry. I might diameter. Get height. I can leave the stream open and eat here while we play. I'm just gonna fetch something real fast. No, I spent so much time working on this. The efficiency is so bad. And find the reasons comment. So obscure. Okay, I think he had the same idea. Plus 1 divided by 2. He did a sort and got away with it. That's cool. Okay, I'm done with this. I'm so tired of everything. So screw this, screw that, screw code, and I'll be back in a few minutes.
Hello there. I am back. And I am ready to get owned at chess again. It's naan bread with some tofu spread on it. It's really more of a snack for me, but it's so good. Wait, let me show you. It's like, you know, the bread from India. It's so addicting. It's almost like eating croissant. But like it's a bit lighter, so I just like eat it non-stop and get fat on it. Okay. So if you want to play now, we can play like a slower game so I can eat at the same time. Otherwise I'm just gonna chill. Alright. No, I forgot to change the category of my stream. Oops. Okay. I added you in my friends, right? Stellar X. Maybe I didn't. No, I didn't actually. 10 minutes is fine. Yeah, I tried to change it up a bit. So I remember your opening with the Sicilian was super scary. I don't even know the opening, and it's like one of the more complex openings, I feel like. There are like so many ideas and so many variations. So like I should never play it, considering that I don't know what I'm doing. But I do it anyways. Sometimes. Oh no. I'm doomed. No, I wanted to go for Scholar's Mate. I think you're free to do whatever you want here. I just realized that I probably don't want to triple my pawns. But I don't really have a choice, don't I? Something went wrong here. Okay, so I have a proposition to make. I'm gonna push my a pawn and I'm gonna try to do a connect four in a four in a row. Hmm. No, fuck. I shouldn't have done that. This looks fine. Yeah, I made a huge mistake putting my rook here. Darn it. Nothing's holding this pawn. Like, even if I back off, so screwed. That's a shame. I'm getting destroyed if I don't get rid of your knight. Like, you were just jumping all over the place and eating everything, so. Not sure if I could do better. Probably. What's my plan here? You may think this is funny, but I'm out of options here. Oh no. Yeah. That's bishop protected now, isn't it? Yep. Well, rip that. Nice. Isn't it? Mhm. Please tell mate, please. Please. No, I can't even stalemate because of the pawn. GG. Something went horribly wrong in the opening. +2, yeah. Slight inaccuracy. So this is actually the my 9. Okay, good to know. Like, I knew this was a move, but I didn't think it was the actual best move. Like, they talked about this in the PogChamps tournament. And they said this move was a slight inaccuracy, but it was okay to play it because you always threaten the Scholar's Mate. Like, it seems it's good actually. Well, okay, so I did this. It's just +1 actually. Yeah, this was my other big mistake. Then I just gave up at that point. Hoped for some magic, but oh yeah, and I lost a piece as well. That's another thing. Okay, a few mistakes. Nothing we can't come back from. Right? Alright, here we go. Whoops. Like, all the people that play against me are like so good so good against the bird because that's all I play, so it's not that as effective when I play my friends. I still enjoy it. It's probably a bad move, but whatever. I think it was better to push the pawn because it just helped your development, and now you just have huge weaknesses.
I missed out on takes. Then you lose your rook. You can bring back your knight. Can you? I can take with my bishop and then take your rook. Yeah, that's pretty nasty, but it's too late. I have other threats up my sleeve. Aha, I see what you're doing. This bishop is useless. This rook is useless. There are many useless things. Okay, push this. You can take, Let's do this. That looks nasty. Do I care about this? I don't think I do. Oopsie.
Let's try everything. Not so sure this was super accurate. Yeah, I was afraid this day would come. Mm-hmm. Let's see what you got. Good, sir. What do I want to do? It's annoying, isn't it? What if I drop my pawn? I think this works, right? Mate and 6. It does work. Let's see how we handle this from the start. -1, okay, blah, blah, blah. Until we don't see anything out of the ordinary. No. Forgot about that. Good old double pawns. Okay. That's a funny move. I didn't even see it. I never see this one. I always want to flank it my bishop, but yeah, you can trade if you want. I don't know if it's at the, yeah, this move I mentioned. I just go back. Might keep developing. Did I win a material here? Or I'm just like, what does this do? Like nothing? Oh, it's trapping your knight. Yeah, that's true. Okay, could trap the knight there. It's good to know. I'll get back. So I played this. And now, oh. What's so good about this? This pawn's going down. I've seen it all, man. You can't confuse me. So you sack this, you threaten mate, and you win the... Wait. Oh, it's not mate, it's just... a pretty decent attack. Okay, I think we went far enough. So we were here. So this, decent. This was just a blunder. Which could kick me away, and then I couldn't protect the pawn anymore and was dropping it. But here I was winning. Yeah, I forgot this move. I saw it after. Okay, I was still okay. Push, 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 push. Yeah, that was a cool ending. Not gonna lie. Not gonna lie. Alright. So there's the lead code weekly tonight. Do you participate in that one as well? Bubba, Bubba, Bubba. Okay. Because I think I'll go like work out and rest a bit before it, instead of staring at a screen like all day. What do you think? Is it a good idea? I think it is. Because my eyes are burning because of the last problem of the contest, man. It was heavy. Hardcore shit. Alright, I'll end the stream here. I hope everyone enjoyed. If there's anyone except you watching, I have no idea. And I hope you have a good evening. Goodbye. Thank you for watching.